Okay, hello everyone and welcome to another maths challenge video. So this one looks ridiculously hard. Let's have a read of it together. So the points K, L, M and N are the midpoints of the edges of the quadrilateral PQRS. Okay? T is a point inside the quadrilateral, so that's here. The quadrilaterals, this and this, have these areas respectively. What is the area of the quadrilateral NPKT, which is this one? So have a pause of the video and have a go at it yourself, and then afterwards we'll try and solve it together. Cool, so for this question, I don't know where to start. It's a geometric question, so I think I'm gonna draw it myself and try and label it as much as possible. Cool, so whenever you have a question and you don't really know what approach you need, it's always good to try and use all the information the question gives you. So one of the key bits of information it gives us is that K, L, M and N are the midpoints of the edges, these ones. Okay, so if they're the midpoints, that means that QL, that distance will be the same as LR, and likewise SM will be the same as MR, and so on. Okay, so let's label that on the diagram. Let's say that this length here is A, then therefore this length here will also be A. B, C, and D. Okay, cool. Now, what should we do next? Finding the areas of weird looking quadrilaterals is quite hard to do. What's easier to do is finding areas of triangles. So what I think I want to do is split these quadrilaterals into triangles. I think that will help my life a lot. So let's do that now. I'm going to do these dashed lines, creating triangles. Okay, cool. Okay, now I've spotted something interesting. Using the formula for the area of a triangle, which is half base times perpendicular height, I realized that the area of this triangle will be the same as the area of this triangle because they both have the same base, which is A, and they both have the same perpendicular height from the point T to their base. Cool. So that means that this area here, let's just call it capital A. That will be the same as this area, capital A. And I can use that same logic for all these other triangles. So now if I look at this triangle here and this triangle here, they will have the same area because they have the same base, which is B, and the same perpendicular height from T to the base. So therefore, let's label these areas capital B and capital B. Likewise, we can do capital C and capital C, and capital D and capital D. Nice. Now I know the areas of some of these quadrilaterals. This one is 20, this one is 24, and this one is 15. Therefore, capital A plus capital D equals 20. So I can create some equations now with my letters. So A plus D equals 20, A plus B equals 24, and B plus C equals 15. And what I want to find is C plus D, because that is my missing X area for this quadrilateral. Cool, so if I'm able to find C plus D, I'm done with the question. So then we need to think, how can we use these equations here to get C and D by itself? And I've noticed something now. What happens if we add this equation and this equation together? So if we add the left-hand side of these equations, we get A plus B plus C plus D equals 20 plus 15, which is 35. Cool. Now what happens when we subtract this equation? If we subtract A plus B from the left-hand side, the A and the B cancel out, so we're left with C plus D. And on the right side, we're going to have 35 minus by 24, which equals 11. Therefore, x equals 11, our missing area, and so the answer is B. And we're done with the question. If you enjoyed the video, check out some of my other ones as well. Bye bye.